into this session, and we will continue GATE 2018 solution. So let's solve question number 21. Remaining 20 questions we have solved in part 1 of GATE 2018. Hope you have watched previous video. If you have not, okay, go to the subscription part and see the link there. Okay, let's solve this one. So you are given a C01 to be a real vector space of all continuous real valued functions on 0, 1, and T is a linear operator given by this. Okay. They're asking the dimension of range space. So we just have to see that range space is spanned by which two vectors or which vectors. So let's consider T of f of x equals integral 0 to 1 sine of x plus y into f of y dy. Now I can consider this 0 to 1. Apply the formula, so sin x into cos y plus cos x into sin y times f of y dy. And now open it, so you get sin x cos y, then f of y dy plus integral 0 to 1 cos x into sin y f of y dy. Now, since the integral is with respect to y, so sin x has no role. I'll take it out. Now integral 0 to 1 and then sin x into f of y dy plus similarly I'll take cos x out and then 0 to 1 sin y into f of y dy. Now I take the liberty to call integral 0 to 1 sin x into f of y dy some c1, okay, because f is my continuous functions and I know that all continuous functions are integrable and sin x is also continuous, so basically this integral will be finite and that will give me some value, so I can call that value to be c1. The integral 0 to 1 sin y into of y dy equal to some c2. So basically I have c1 sin x plus c2 cos x, okay, so that is spanned by linear span of sin x and cos x. So T of f of x is this. That means this is nothing but the range. Okay, so range is spanned by two vectors, namely sin x and cos x. So dimension of range space is 2. Okay, so dimension of the range space is 2. Now let's solve next one. So here you have to apply the quadrature rule, and it says this quadrature rule has minus 1 to 1 f of x is exact for all polynomials of degree less than or equal to 3. That means we can play the game for 1x, x square and x cube. Okay, they want 3a square is what? Okay, so let us solve. So can I take an odd function? Okay, taking an odd function will give me nothing. Okay, if I take here 1, okay, that will not play any game. Once again, something is wrong with the device again. It's not working. Just a second. Okay, so it's fine now. Let's begin. So what if I apply the quadrature rule for this constant? Okay, I will have a problem because if I do this, watch it, minus 1 to 1 dx will be same as f of minus a plus f of a. Then this quantity right here will give me here 2, and that will be equal to here I'll get 2. Okay, so this gives me nothing. Okay, I got nothing because they want 3a square. So, and if I take x, then x is an odd degree polynomial. Okay, it will give me 0. So I can only play with x square because x cube is again odd. Okay, so it will again give me 0. So I have to take only x square. So minus 1 to 1 x square dx would be equal to f of minus a plus f of a. Note that I have taken f of x to be x square. Okay, So f of minus a will be again a square, and f of a will be also a square. And if I solve this, then this is an even function. So that will give me 2 times integral 0 to 1 x square dx would be f of a is a square plus a square. Okay, so it will be 2, and x square, if I integrate between 0 to 1, I get 2 over 3 equal to 2a square. Okay, so this 2 and this 2 gets cancelled, take it here. So you get 3a square equal to 1, and this is what they wanted. Okay, so it is solved. And now let's solve this one. So you have gamma be a circle given by z equal to 4 times e power I theta. So this 4 represents here radius of that circle is 4, and theta is from 0 to 2 pi, and we need to find out what is the value of this integral. So instead of evaluating this integral, let's evaluate cos residue, okay, because that will be quite easy. So let's go and evaluate the residue here, because we know that integral over c times f of z dz is nothing but 2 pi I into sum of all residues. Okay, so if you consider denominator, okay, so z square minus 2z equal to 0, that means z into z minus 2 equal to 0. So z equal to 0 and z equal to 2 are two singularities. These are the two singularities, and they both lie in gamma. Okay, because gamma is a circle of radius 4. So if I have a circle of radius 4, okay, then 0 is inside and 2 is also inside. Okay, so we will find out the residue at both these points. So residue of f at z equal to 0 will be equal to what? Limit z tends to 0 z into f of z. So that will give me limit z tends to 0 z times what I have is e power z upon z into z minus 2. So I get this, and this gets cancelled, and at z tends to 0, this power will be 1 and minus 2. So I got residue 1 is minus 2, and then residue of f at z equal to 2. Okay, it will be again limit z tends to 2 to be again z minus 2, and since all of them are simple, okay, they are simple poles basically. Okay. They all have order 1, so there is no need to worry. And it will give me limit z tends to 2 and z minus 2 into e power z upon z into z minus 2. And this part goes away, you get e power 2 over 2. And I need now integral over c f of z dz. That will give me 2 pi I into sum of the residue. What is this sum of the residue? Once again, yeah, 1 is minus 2, so minus 1 over 2 and plus e square over 2. Very nicely, I can write down this is 2 gets cancelled. I simply have pi I times e square minus 1. Okay, so the answer is pi times e square minus 1. So the answer is C. Okay, pi I times e square minus 1. Yeah, and let's solve this one. Here you have the image of the plane. So you have to consider image of the plane. Okay, the plane should be this, such that real part of z plus imaginary part of z is greater than 0 under this map. That means f of z equal to z minus 1 upon z plus I. Okay, where it will give. Okay, that means if I take any z such that this is satisfied, then where does this go? Okay, so to solve such kind of problem, it is better to take one point and discard the remaining options. So what if I get z equals to 1? Okay, so if you see here, then real part of z equal to 1 and imaginary part of z equal to 0. And real part of z plus imaginary part of z is greater than 0. Okay, so let's check. So it will be 1 minus 1 upon 1 plus I, and it is 0. Now I need to check where will this lie. Okay, so I got this to be 0. Okay, that means W is 0. And what the first option is saying, okay, the real part of W is greater than 0. So option A is wrong. It says imaginary part of W greater than 0. Again, it is wrong. And then you have mod of W greater than 1. Here, I'm getting W to be 0. So you can see option is wrong. D has to be true. Okay. So this was the most easiest thing that you could do. Okay. And now let us solve this one. So this is again a problem from double integral. So here you have D from R2 subset to disc center at the origin and radius 2. Okay. Radius is 2. So we are concerned about this thing only. Radius is 2, that means 2 comma 0. And then you want this. Okay. So double integral over d e power minus of x square plus y square dx dy. We will now take it to polar r and then solve. Okay. So the region d dash and then e power minus of r square into r dr d theta. I hope you know that this r is nothing but the Jacobian while transforming this. So, and in this region, your r is from 0 to 2 and your theta is from 0 to 2 pi. So 0 to 2 pi and then 0 to 2 e power minus r square into r dr d theta. So I'm not going to make any substitution, rather I just adjust this function and its derivative here. So derivative of minus r square is minus 2r. So I'll just adjust minus 1 by 2 here. Okay. So I get minus 1 by 2 and integral 0 to 2 pi. This will be simply e power minus r square, and then integration of this will be from 0 to 2 and then d theta. So that will be half. And since there is no sine and cosine, so I can simply take this 2 pi outside. Okay. And here I'll get e power minus 4 and minus 1. Okay. So this 2 and 2 gets cancelled. So I get pi times, once again, pi times e power minus 4 minus 1. None of the options are correct. Why? Just a moment. Yeah, I'm sorry, I forgot this minus. Okay. So because of this minus, this will make it pi times 1 minus e power minus 4. Okay, I'm taking minus common from this minus. It will give me this. Okay. So I got pi times 1 minus e power 4. So A option is correct. Okay, for 28, A option is correct. Now let's go further. Okay. So that will give me, yeah, now look at this. Problem 29. It says you have a polynomial p of x equal to x power 4 plus 4. And what it is asking that in the ring Q of x, this is the reducible set of zeros form a group under multiplication, and the splitting field of P of x has degree 3 over Q, and the splitting field Px has degree 4 over Q. Okay. What is the max thing that I can do here is x power 4 plus 4. So since I am in Q now, okay, so can I do this? Instead of x power 4 plus 4, I can adjust them into this form, square plus, one second, this will be wrong, just a moment. Yeah. So P of x is x power 4 plus 4, and I have to check whether this is reducible or not first, because there is option B even, and I have to find out its set of zeros. So let us first expand this and write down x power 4 plus minus 4. Okay. Can I do this? 4x square minus 4x square, because I found that this is nothing but someone's square. So what if I write down like this? It is nothing but x square plus 2 whole square, correct? This much. And this part will be minus of 4x square. Okay. And you can now split it. So x square minus 2x plus 2 into x square plus 2x plus 2. Okay, I'm simply applying the intermediate formula. Instead of writing this 4x square, one can also take the liberty of writing this 2x whole square, and I'm using a square plus b square, so a plus b, a minus b. And now you can see that these two are not the units in Q, okay, and they are of lower degree. It is of degree 4 and they are of degree 2. That means what? P is reducible. P is reducible. So here P got reduced. And if you want to find out its zeros, okay, if you want to find out zeros, then what they are saying that the set of zeros of P of x in C form a group under multiplication, okay. So if you find out its zeros, then P of x equal to 0 implies x square minus 2x plus 2 into x square plus 2x plus 2 equal to 0, okay. So if they form a group under multiplication, there should be the multiplicative identity 1, okay. There should be multiplicative identity 1, and I see that 1 is not there. 1 is not the root, so basically they do not form the group under multiplication, so option A is wrong. B is true, being MCQ. And the splitting field of P of x has degree 3 over Q. Okay. This will be wrong because splitting field of has degree 3 over Q, okay. Splitting field of Q I over Q. They have got imaginary roots. So Qi over Q is what? Degree of Qi over Q. So degree of Qi was 4 and degree of Q we found to be 2. Okay, so this is 2. It is saying degree 4, degree 4. Okay, they are all wrong. Okay, let's solve question number 30. And it says which of the following statement is true. So it says every group of order 12 has a non-trivial proper normal subgroup. Okay, so let's find the counter example for them. It is true or not. If you can't counter them, then it will be wrong. Okay, so every group of order 12, that means we take any group, okay, it has a non-trivial proper normal subgroup. Fine. Well, I cannot think of any example right now. Let me check another one. Some group of order 12 does not have a non-trivial proper normal subgroup. Okay, so in that case, even I can't think of an example. Wait, let's see. Every group of order 12 has a subgroup of order 6. Every group of order 12 has a subgroup of order 6. Well, now this is not true, because though you may think that 6 divides 12, so it should have, but there is one standard example, A4. Okay, so order of A4 is 12. Okay, order of A4 is 12. Okay, and it has no subgroup of order 6. It has no subgroup of order 6. So this is wrong. Every group of order 12 has an element of order 12. You can take D6, dihedral groups. Okay, D6 has no element of order 12. Okay, D6 will work. It has no element of order 12. One second. No. D6 is order 12, right? So D6, if I have to write down, then it will be alpha, alpha square, alpha cube, alpha 4, alpha 5, alpha 6 equal to identity, beta, alpha beta, alpha square beta, alpha cube beta, alpha 4 beta, alpha 5 beta. Okay, so these are total reflections. Okay, they are of order 2, and the remaining part is isomorphic to Z6. Okay, and yes, Z6 has no element of order 12. Okay, so D option is also false. Right, now from remaining A and B we have to see. Okay, so it is saying that some group of order 12 does not have a non-trivial proper normal subgroup. Now we can't say anything about directly without applying CELO. So consider CELO and apply this. So 2 square into 3. Okay, so now we want number of subgroup of order 4 will be of the type, okay, will be all collection of 2k plus 1 which divides 3. Okay, so it is true only for k equal to, how many are there? 2k plus 1. It can be 3 or 1. Okay, because 1 and 3 only divide, and it is true. And let's check for this. So number of subgroup of order 3, it will be 3k plus 1 should divide 4. So it is only possible when k is 1. That means 4 is there, okay, and 1 is there. Okay. Now, so number of subgroup of order 4 and number of subgroup of order 3. So there are possibilities. It can be 3 or it can be 1. If it is, it can be 4 or 1. If it is just 1, then I can say that that will be normal. Okay. But since there are 3 and 4, so we have to consider the choices. Okay. So suppose there are 3 subgroups of order 4. Okay. So let's fill them. Let's say H1, and you have H2, and you have H3. Suppose 3 subgroups I got. Okay. So let's fill them. Say element 1, element 2, and element 3 followed by the identity. Okay. And then element 4, element 5, element 6 followed by the identity, element 7, element 8, element 9. How many elements have been utilized? 9 of them have been utilized. Okay. 9 of them have been utilized to make group of order 4. So how many elements are left? 3. So 3 elements are left, and it is saying that number of subgroup of order 3, they possible are 4 or 1. So I cannot make 4 now because I have only 3 elements left. So I'll form a subgroup of order 3. So A10, A11, and A12. Now, if you noticed, then there is a problem. Okay, 18, A11, A12, E. Oh, sorry, identity is used. So I can have a group of order 3. So that means this choice is possible. Okay, so what it says that some group of order 12 does not have a non-trivial proper normal subgroup. See, we found one. Okay, we have found one group of order 3. Okay, which is normal. Okay, because there was only one. Okay, remaining 3 elements I can feed into the different subgroup, and that will be only 1. So if the subgroup is only 1, then that will be normal. But it is saying that some group of order 12 does not have a non-trivial proper normal subgroup. But I found one proper normal trivial subgroup. So this option will be again wrong. So option A will be true. Okay, option A will be true. Now look at this one. So for an odd prime p, consider a ring. So just remember this one thing. Okay, z under root minus p, okay, is not a UFD for p greater than or equal to 3. So let's take p to be equal to 3 because it says for an odd prime. So p is 3. Okay, we can't take 2. So if p is 3, then it's not a UFD. Okay, UFD. And now if you know the sequence, then I, U, P, E, F. So first CRU becomes integral domain, and integral domain then become UFD, and then it becomes PID, and then it becomes Euclidean domain, and then it comes to the field. So the step goes like this. Well, instead of writing this, let me draw the correct sequence. Okay, so you have here I, integral domain I, U, P, E, F. So it is not a UFD. Okay, it's not a UFD means it will not be PID, it will not be ED, it will not be field because it failed at the step 2 only. So it is just an integral domain. And you have here element 2. It's not a UFD means you can't factorize 2. You can't write 2 as some product of 2 elements. Okay, distinct element. Okay, you can't write because this is not possible. Okay, because the ring is not in UFD, so it doesn't have a unifactorization domain. That means what? 2 can't be reduced. So the only option that seems true is irreducible. Okay, 2 will be irreducible. Okay. Now let's solve this one. So you have to find out the characteristic curve. This is quite easy. So here you just have to compare it with the canonical form. So that is A UXX plus B plus function of x, y, z, p, q, okay, equals 0. So I don't need it because all I'm concerned about this a, b, and c. So if you compare this with the standard equation, you get a equal to x, and there is b equal to 2x square, and there is no c. So c is 0. Okay. So the equation for equation for characteristic roots is says you have a times once again, yeah, so a lambda square plus b lambda plus c equal to 0. So now just substitute, so you get ax square, sorry, a is x, so I get x lambda square, b is 2x square lambda, c is 0, so just write down there. Now I can take x lambda common, and that will give me lambda plus 2x equals 0. So my x cannot be 0, because if x is 0, everything will be 0. So here lambda should be 0, or lambda should be minus 2x. So the characteristic equations are given by, dy over dx plus some lambda 1 equal to 0, and dy over dx plus lambda 2 equal to 0. We got two lambdas, so let's find out. So that will be dy over dx plus 0 equal to 0, and then you have dy over dx minus 2x equal to 0. Let us solve them. So here you get dy by dx equal to 0 means y equal to some constant, and here you get dy over dx equal to 2x. So instead we can take this dx that side and get y equal to x square plus some c2. So c2 will be equal to y minus x square. So we got two characteristics. C1 is y and C2 is y minus x square. Okay, so one second. You can also shift it and say C2 dash equal to x square minus y. That does not make any difference, because options did not have y minus x square. It was x square minus y. So x square y minus y is in option A and option D. So this B and C gets cancelled, and your C1 was y. So the only option is correct is option A. Okay. Now let's solve this problem from LPP. Okay. Yeah, so let's solve this one. And you have to maximize alpha x1 plus x2 as subject to the constraint. So let us draw the constraint first. Okay. So let's draw them. 2x1 plus x2 is 6. That means I have x1 over 3 plus x2 over 6 equals 1. So this will be 3, 0, and this one will be 6. Okay, so if I draw the line, in this line I have for 2x1 plus x2 less than or equal to 6. Okay, and then x1 plus x2 is less than or equal to 4. So this point is my 3, 0. This point is 0, 6. This one will be 4, 0. It will be 0, 4. So I also get this point is now 4, 0. This point is 0, 4 for this line. So then now let's solve this one. So you have here minus 1, 0 is here somewhere. No, minus 1, 0 is here. Okay, and 0, 1. Okay, it will be here somewhere. So it passes through this. And now what we have is, it is saying that for this line we have less than or equal to. Yeah, it's less than, even this is less than. And then what we have is everyone is less than. So this is the common region. Okay, this is the common region. We need to find out these points are. So 3, 0, 4, 0. Once again, the line is 2x1 plus x2 is 6, and this line is x1 plus x2 equal to 4. So if I put here x2 equal to 4, I get x1 and x2 to be, once again, this gives me 2 satisfies 2 plus 2 4, and 2 into 2 4 plus 2 6. So this point is 2 comma 2 satisfied. You can even solve it. Okay, I'm just checking which will satisfy. And here you have x1 plus x2 equal to 4, and this line is x plus y minus x plus y equal to 1. Okay, so we need to solve this now. X1 plus x2 is 4, and minus x1 plus x2 is 1. So if also this gets cancelled, 2x1 equal to 5. So x1 is 5 by 2. So x1 is 5 by 2. So x2 will be 4 minus 5 by 2. So 4 into 2 is 3 by 2. So this point will be 5 by 2 comma 3 by 2. Okay. And then what I have here is 0 comma 4. Okay, we found all. Now let's find out. So z at 0 0, it is inside. So z at 0 0 will be 0 because we have to maximize. And z at 3 comma 0, it will be 3 alpha. And z at 3 by 2 comma 5 by 2 will give me alpha times 3 by 2 plus x2 is 5 by 2. Okay, so that gives me 3 alpha plus 5 over 2. And what is next? At 2 comma 2. So z at 2 comma 2, what I get? 2 alpha plus 2. Okay, so now, and since alpha is a constant, okay, and 3 comma 0 is the only optimal solution. Okay, it is also given that 3 comma 0 is the only optimal solution. So in that case, what I have is, that means this is the optimal solution, means all the solutions must be less than that. Okay, all the optimal solutions must be less than that. So means this is also less than this quantity, 2 alpha plus 2 is also less than this. So I can take 2 alpha plus 2 is less than 3 alpha. Okay, because 3 alpha is optimal. Okay, 3 comma 0 is the optimal. That means since the problem was to maximize, so all of them must be less than the 3 alpha. So just take their alpha. So you get alpha greater than 2. Okay, D option is correct. And this is solved. Now let's solve sum number 40. While it says you got 2 cross 2 real matrices of the field R, and you have a transformation S from M to R given by this. Okay, so trace of S they want. This is quite easy, but a lengthy one. Still, we will try to make it short. So first consider the basis, standard basis for M2, that is 1 0 0 0, 0 1 0 0, and 0 0 1 0, and 0 0 0 1. Okay, standard basis of M2 be the standard basis of M2R. Okay, and now let's find out S of 1 0 0 0. So it said that it is 2 times this quantity plus the transpose of this. So that gives me, the transpose will remain same because this is a just 1 0 0 0. So I get 2 0 0 0 plus 1 0 0 0. That gives me 3 0 0 0. Okay, and then I got S of 0 1 0 0. That will give me 2 times 0 1 0 0 plus its transpose will be 0 1 0 0. Okay, that gives me if I add, so I get 0 2 1 0. Okay, now let's find out the next one. So S of 0 2 0 1. So 0 0 1 0 0 0 1 0 will give me 2 times 0 0 1 0 plus the transpose will be 0 0 1 0. So that again gives me 0 1 2 0. Okay, and then S of 0 0 0 1 will give me 2 times 0 0 0 1 plus the transpose of this matrix will be 0 0 0 1. Again same thing. So I get here 0 0 0 3. Okay, so the matrices that we have obtained, we have to write down in the linear combination. So that is, the first matrix that you got is 3 0 0 0, and the second we have is 0 2 1 0, and the third one is 0 1 2 0, and the fourth one is 0 0, 0, 3. So we have to write down in the linear combination of standard basis. So that is 3 times 1, 0, 0, 0 plus everything will be 0 now. So now if you noticed, then directly we can write the matrices as the column, okay? Because 3, 0, 0, 0, and here it will be 0 times the first matrix plus 2 times the second element, then 0 times the third one plus 0 times the fourth one, okay? So this is what I mean to say. Okay. Later I'll write down E1, E2. Okay. Plus E4, and the same thing here. So if you construct a matrix, you get T with respect to this matrix is, I'm sorry, M with respect to this matrix is, just write down the column. So 3, 0, 0, 0, 0, 2, 0, 0, 0, 1, 2, 0, 0, 0, 0, 3. Okay. So trace of S is equal to 3 plus 2 plus 2 plus 3. Okay. So that gives me 10. So the answer is 10. Okay. So the answer is 10. Now let's consider this one. So it is saying that you are given that R3 with usual inner product, and D is the distance from this to the subspace of spanned by this. Okay. So let W be the subspace spanned by these two vectors. So alpha times 1, 1, 0 plus beta times 0, 1, 1. So that alpha and beta belong to set of reals. Okay. So let us write down this. That will be alpha, alpha 0 plus 0 times beta, beta. So alpha and beta belong to set of reals. So it is nothing but the spanned by these two vectors, alpha, alpha 0 and 0. Once again, it is meaningless. Rather, we write down the subspace only because we want the distance. Okay. So that will give me, it will be simply alpha, and this part will be alpha plus beta, and this will be simply beta. So that alpha and beta belong to set of real. So this is subspace, and what they want, if D the distance from 1, 1, 1 to the subspace of this. Okay. So I'll take D is nothing but the, see, it is the usual inner product. That means the distance is given by the normal matrix, that standard metric. So I have 1, I want the distance from 1, 1, 1 to this space. Okay, so that will be alpha minus 1 square plus alpha plus beta minus 1 square plus beta minus 1 square. Okay, so this is what it's there. Now I need to find out the distance. Okay, so it is this distance. So I'll rather say it is d square, and remove this d. Okay, and I have to minimize this. So then I call this d square to be some capital D, so that I'll differentiate del D with respect to alpha. So and that gives me 2 times alpha minus 1 plus 2 times alpha plus beta minus 1. Okay. Then del D over del beta, that will also give me the same thing. So 2 times alpha plus beta minus 1 plus 2 times beta minus 1. Okay. So now for the extremes, we have to equate them with 0. Okay. So del D over del alpha should be 0. This implies 2 times alpha minus 1 plus 2 times alpha plus beta minus 1 equal to 0. So if I solve, then I get alpha minus 1 plus alpha plus beta minus 1 equal to 0. So here it will be 2 alpha plus beta equal to 2. So call this equation 1. And with respect to beta also equate with 0. So I get same thing, I think. So 2 times beta minus 1 plus 2 times alpha plus beta minus 1 equals 0. So here I get 2 gets cancelled. I get alpha plus 2 beta equal to 2. I got this 2. Now I just need to find out this alpha and beta by solving these two equations. Okay. So if I solve them, I have to multiply this equation with alpha. So 2 alpha plus beta equal to 2. I'll multiply this by 2 and write down in different ink so that you understand. So 2 alpha plus 4 beta equal to 4. Now let's solve them. So minus, minus, minus. This gets cancelled. Okay. And I get minus 3 beta equal to minus 2. So this implies beta equals to 2 by 3. Once I got beta equals 2 by 3, I can find out alpha. Okay. I can find out alpha now. So alpha is given by 2 minus, 1 second. Let me rather put it. So 2 alpha plus beta is 2 by 3 equal to 2. So this implies 2 alpha will be equal to 2 minus 2 by 3. So 2 alpha will be equal to 3 into 2, 6 minus 2, 4 by 3. So alpha is also 2 by 3. So I got alpha and beta both 2 by 3. Now let us substitute here and find out the distance. Okay. So for that purpose, I'll erase this entire part. It's not even erased. Okay, this is sufficient. I need d square, right? So just find out d square here. So alpha is what? 2 by 3 minus 1 square plus 2 by 3 plus 2 by 3 minus 1 square plus beta is again 2 by 3 minus 1 square. Okay. So to square this, let us find out 2 by 3 minus 1 will give me what? Minus 1 by 3 square. And this one will be 4 minus 3. That will again give me 1 by 3 square and plus again minus 1 by 3 square. Okay. So this is nothing but 3 times 1 by 3 square is your d square. Okay. So what they want is 3d square. So 3d square should be 1. No, not 1. Now I want 3d square. So 3d square would be equal to, here it will be 9. And then it will be 1 upon 9. Yeah, it is 1. So 3d square is 1. Well, now let's solve 42. So what it's saying that A is your identity minus 2 times U transpose into U, where U is given by this. So they are asking the two distinct eigenvalues of A, then mod is mod of lambda minus mu. Okay, so let's solve this. Instead, we directly find out the eigenvalues and write this as a matrix of 1, 1, 1, 1, 1, and so on up to 9 cross 9 times, right? And rest of them are 0. So this is my identity minus 2 times, watch it. This is 1 by 3 and then multiply by this. So that gives me ultimately 2 into 1 over 9 and then U transpose. So that will give me 1, 1, 1, 1, 1 and so on up to 9 times here and 1, 1, 1, 1, 9 times, right? So if I construct the matrix, that will give me 1, 1, 1, 1, 1, minus 2 over 9 times. This will be again 1, 1, 1, 1, 1, 1. Just 1. Okay. So this is again 9 cross 9, 9 cross 9. So eigenvalues of this matrix are simply 1, 1, 1, 1 to 9. These are the eigenvalues. Okay. Minus 2 by 9 will remain here. And eigenvalues of this matrix are, see, this is a 9 by 9 matrix. So one of the eigenvalue will be 9 and the rest of them will be 0. Okay. So I can take this 1, 1, 1, and so on, minus 2 times take 9 inside. So you get 0, 0. Sorry, it will not 0, it will be 1. Okay, 1, 0, 0, 0, and so on. And now let's find out the eigenvalues of A. So it will be 1 minus 2, pairwise, minus 1, 1, 1, 1, 1, 1, 1, so up to 1, 9 times. Okay. So these are the eigenvalues of A. Okay. So the largest is 1, smallest is -1. So mod of lambda minus mu equal to mod of 1 minus -1, that will give me 2. So the answer is 2. Okay. Well, now let's solve this one, the most easiest problem, 43. It says you are given a circle of circle z equal to e power I theta, where theta varies from 0 to 4 pi. Okay. And they want this. So we know that integral over 1 over 2 pi I times integral f dash z on f of z dz equal to number of zeros minus number of poles. Argument principle. Okay. Number of zeros minus number of poles. So all we are concerned about this f of z. So f of z equal to z cube into e power z square. Okay. So number of poles of f, this function has got no poles. Okay. So number of poles of f are 0 and number of zeros. Okay. So it has got this quantity can't be 0. So only this will be 0 and it ordered 3. So number of zeros are 3. But here out, so this integral will be basically number of zeros minus number of poles. That will be 3. But answer is not 3 because theta here is from 0 to 2 pi. That means in one oscillation, when it revolves once, the answer will be 3. But we have to take it one more time. Okay. So it will be 2 times 3. So that will be 6. So answer is 6. Okay. Now let's solve this. So we use the surface of this solid and denotes the outward with normal integral f into n. Well, we can apply Gauss divergence because we simply know that f into n ds is nothing but divergence, okay, of f times surface volume integral. So we just need to find out divergence of f. So divergence of f will be equal to, okay, just simply differentiate it with respect to x, I component, with respect to y, with respect to z. So I get 1 plus 1 plus 1. You give me 3. So it will be simply 3 times over dv. Now this integral f into n ds will be triple integral of, take this 3 common, and it will be dx, dy, dz. Z is moving from 0 to 3, y is moving from 0 to 2, and x is moving from 0 to 1. Since here it is 1 and all the limits are constant, so they will be simply multiplied. So 3 minus 0 into 2 minus 0 into 1 minus 0. So that will give me 3 into 3 into 2 into 1. So answer is 18. Okay. So it will be 18. Now look at this one. This is again quite easy. You are given a solution. So they want the sum of the diagonal entries of A. So remember, it's a 3 by 3 matrix. So x dot t is like dx over dt, okay, equal to A times this x of t. Okay. So this A will be a matrix of 3 over 3. Since this, if you look at the solution very closely, then you see that e power t, e power 2t, and e power minus t. It's a linear combination of these three things. So that means 1, 2, and minus 1 must have been on the, it's a real entries, right? So I can take this matrix. Okay, I can take this matrix because the solution is given by c1 into e power m1t plus c2 into e power m2t plus c3 into e power m3t. This is how we get the solution. The solution is given in terms of e power t. That means m1 must be the root. So the root, if I have, then it should be one of the eigenvalue because these are eigenvalues. Okay, m1, m2, m3 are the eigenvalues. Since I have here is eigenvalues are, I directly find out the eigenvalues. Eigenvalues are 1, 2, and minus 1. What they want is trace. So trace, sum of diagonal entries is nothing but a trace. Trace is nothing but the sum of the eigenvalues. Okay, trace is nothing but the sum of the eigenvalues. So that will be 1 plus 2 minus 1. So it will be simply 2. Okay, you don't have to solve the entire problem even. And now look at this one, 46. What it says, you have y1x equal to e power minus x square, which is the solution of this differential equation. Then alpha into beta is what? Okay, then alpha into beta is what? So since y1 is a solution, that means it will satisfy this differential equation. Okay, it will satisfy. So let us find out y dash first. y1 of x is e power minus x square. So y1 dash will be minus 2x into e power minus x square. Y1 double dash will be minus 2 times, it will be minus 2 x square into e power minus x square, and then plus your remains such as derivative of v plus derivative of v, and then u derivative. Yeah, that's fine. And now I need x times y1 double dash. X times y1 double dash will be given by 4x cube into e power minus x square and minus 2x into e power minus x square. Okay, and then I have alpha into y dash, alpha into y1 dash, that will give me minus 2 alpha x into e power minus x square, and then I have beta into x cube y, so that will give me beta into x cube e power minus x square. Okay, now just add these three. Okay, if I add all of them, because I need to substitute in this formula, okay, to get alpha and beta, so that will give me, if I add, so can I take e power minus x square common first, because it is there in everyone. So it will be 4x cube minus 2x minus 2 alpha x and plus beta x cube into e power minus x square equal to 0. Okay, so now just equate the coefficient. So b plus 4 into x cube, okay, minus 2 times alpha plus 1 into x equal to 0. Okay, so this is a polynomial equated with 0. So this implies b plus 4 is 0 and alpha plus 1 is also 0. So this implies beta equal to minus 4 and alpha equal to minus 1. So alpha into beta will be 4. So the answer is 4. Okay, now let us solve question number 47. So it's L2 be a Hilbert space of all real valued square integrable functions on 0, 1 with the usual linear product, and phi is defined to be the linear functional on L2 defined by this quantity. So we have to find out the Lebesgue measure. We have to find out the norm of this phi. Okay, to solve such kind of problem, okay, use a Rees representation theorem. It's better to use a Rees representation theorem. Now, what does Rees representation theorem says? So it says that if you have a bounded linear functional, okay, a bounded linear functional on a Hilbert space, a bounded linear functional on a Hilbert space can be represented in terms of inner product, in terms of an inner product. That is, if f is a bounded linear functional on H, then this f of x can be written as inner product of x with G, okay, for all f belonging to H, the Hilbert space, okay. And this G depends on x. Depends on f, okay. G depends on f, and norm of G is same as norm of f, okay. So instead of calculating the norm by suppressing it with some inequality, it's better to use the Rees representation theorem. And see, we have got here linear function, so we have to check whether phi is bounded or not. See, in the exam, if they are asking norm of phi, then they will ask if this is bounded. Otherwise, we can't apply Rees. So we will not check it is bounded or not. We will directly find out norm of phi. Okay, but remember that this theorem is ideal only for bounded linear functional. So we need to find out norm of phi. So let us find out norm of phi, what it will be given by. Okay, so consider this. First find phi of f. Okay, so phi of f is from 1 by 4 to 3 by 4, 3 root 2 times f d mu. Okay, now this is on 0 to 1. So can I write it Can I write it in this manner? From 0 to 1 by 4, I can take a function f0 d mu plus 1 by 4 to 3 by 4. It will be 3 root 2 d mu plus 3 by 4 to 1. It will be again 0 into f d mu. Is it fine? Now, this is nothing but inner product of f comma g, where g is given by what? 0, 3 root 2 and 0. 0 when 0 is less than x is less than 1 over 4. 1 over 4 is less than x is less than 3 over 4. And 3 over 4 is less than x is less than 1. So instead of finding the norm of this phi, I'll now find out the norm of this g. Okay. So the norm of g, so norm of g will be given by, norm in L2 is given by 0 to 1 mod of g square d mu power half. Okay. This is the norm in L2. This is the norm in L2. So let us find out. Again, do the same thing. So you have from 0 to 1, just split it. Okay. And go from 0 to 1 by 4 times mod g square d mu plus 1 by 4 to 3 by 4 mod g square d mu plus 3 by 4 to 1 mod of g square d mu power half. Okay. And now I have no space even to utilize. Okay. Instead I'll utilize this column. Okay. So this part right here will be 0 because between 0 to 1 by 4 the function is 0. So this quantity will be 0. This quantity will be 0. All I have to calculate is this. So between 1 to 4, 3 by 4, mod of g is 3 root 2. Okay, so 3 root 2 square d mu power half. Okay, just evaluate. So you get 3 root 2 coming outside. Okay, and then it will be 3 by 4 minus 1 by 4 power half. Okay, so that will give me 3 root 2, and this one will be 1 by 4 power half. No, sorry, I'm sorry. 3 minus 1, 2 by 4 power half. So 2 by 4 is nothing but half power half. So root 2 and root 2 get cancelled. You get 3. Okay. So since norm of g is 3. Okay. So I'll write it down. Since norm of g is 3. So by reason, norm of phi is also 3. So answer is 3. Okay. And now let us solve this one, 48. It says U is an orthonormal set in the Hilbert space H and X belong to S so that norm of X is 2. And you have to find out what is the maximum possible number of elements in E. Okay, so what is this set? First of all, it's collection of U. One second. Instead of solving it like this, I can consider let M be the number of elements in E. M be the number of elements in E. Suppose there are M elements. So that means this E is nothing but Ui belonging to U such that mod of inner product of X comma Ui is greater than or equal to 1 by 4 for I running from 1 to M. Okay. Now, the goal here is to apply Bessel's inequality. Okay. I want to apply Bessel's inequality. What does Bessel's inequality says? That is, if you have summation, okay, summation mod of X comma, inner product of, if you have an orthonormal basis, inner product of X comma Ej, J runs from 1 to, you can even take finite, infinite. So since we want finite number of elements, we will take n. Okay, this square is always less than or equal to norm of X square. We want to apply this. So right now what you have, so you are given since mod of inner product of X comma Ui is greater than or equal to 1 over 4, Now we will take square on both sides. So inner product of x comma ui square will give me 1 over 16. Okay. Now take the summation. So j runs from 1 to how many elements are there? M. So take up to M. So x comma ui square will be greater than or equal to. So will be again summation j equal to 1 to M 1 over 16. Now this one will give me summation j equal to 1 to M the product of x comma ui square. I'm sorry, this is not square inside, it is outside. Okay, so this will be outside and then this will be M by 16. Okay, now just notice, since M over 16 is less than or equal to, rewriting this inequality in the reverse manner. Okay, so this will be j equal to 1 to M inner product of x comma ui square, but we know that this quantity is less than or equal to norm of x. Wait, I have no space here. Mod of inner product of x comma ui square is less than or equal to norm of x, norm x square, but we are given that norm of x is 2. Okay, so therefore m over 16 is less than or equal to 2 square. So m over 16 is less than or equal to 4. So m is less than or equal to 64. We want the maximum number of elements possible are 64. So because we got m is less than or equal to 64, so 64 is the maximum. Okay, so there can be only 64 elements in this set. Because here u was given to be an orthonormal set, so we applied basis inequality. Okay, and now let's solve this 49. Okay, so let us solve 49 now. Even this sum is quite simple. See, I'll not apply Lagrange interpolation because it is given that p of x interpolates the point this. Okay, so I'll use one of these points and find out this value. Okay, what it gives me. So let's consider you are given to be p of x equal to 2 minus x plus 1. I'll take x plus 1 common, in fact. So 1 plus, it will be 1 second. If I'm taking minus, then there will be a problem. Keep it here plus. So I got here minus 1 plus x and then minus beta times x into x minus alpha. Okay. So let us consider points which will give us something. If I take p of minus 1, okay, if I take p of minus 1, yeah, so take p of minus 1, so that will give you what? F minus 1 will be 2. So if I'm putting x is minus 1, I'm getting y to be 2, that is p of x. So p of minus 1 will be 2 plus this entire quantity will be 0, right? It's minus 1 plus 1 into. So we don't have to worry. P of minus 1 is 2. So we got 2 equal to 2, means we got nothing. Okay. Because we want alpha and beta to be alive. So we did not use this. P of 0 equal to 1. Let's see what that gives me. P of 0 equals to 1. Okay. So if I put P of 0 equals to 1, then this quantity right here will be 0. And this will be minus 1 remain and 2. Again, I'm not getting anything. So even this is not useful. Let's take P of 1 equal to 2. Okay, so P of 1, see what it gives us. So P of 1 equal to 2. Let's apply this. So I get 2 equal to 2 minus, let's apply here, 2 minus 2 into, it's not useful, okay. 2 equals to, this is 2 minus 1 plus 1, 2 plus 1 into 2 will give me again 2 minus beta into, it is 1, so it will be simply 2 beta, okay, and then 1 minus alpha, okay, 1 minus alpha. So I see that 2, 2, 2, 2, all of them get cancelled. So this implies minus 2 beta into 1 minus alpha will become 0. So this implies either beta equal to 0 or 1 minus alpha equal to 0. Okay, but if beta becomes 0, then what? Okay, if beta becomes 0, then what? So from here I'll say that alpha is 1. What happens if beta equal to 0? If I put beta to be 0, then these equations will not hold. Okay, these equations will not hold. You can put it here. Suppose if beta is 0, then this will be simply entire quantity will be 0. So you get p of x equal to 2 minus x plus 1 plus x into x plus 1. Now put, okay, and verify. Are you getting, if you put 1, are you getting 2? So p of 1 equal to 2 minus, this will be 2 plus 1 into 2, 2, and here I'm getting 2. I think this is satisfied, right? Yeah, this is satisfied. So which of the following equality is not satisfied? We need to check. One of them will not be satisfied because if I take beta to be 0, okay. Well, so let's take this one and check. Put minus 1 now. So if I put minus 1, then this quantity will be 0, this quantity will be 0, and this one will give me again 2. What happens? Beta is also satisfied. Add 2, let me see if I'm getting 7 minus 7. That will play the game. Okay. So if I put 2, am I getting it? So minus 7 equal to 2 minus, I have here x is 2. So 2 plus 2, 2 plus 1, 3, plus 2 into 2 plus 1, 3. So 6, 3 into 2, 6, plus 2, 8. 8 minus 3 equal to 5. And here I have minus 7. So that's why beta cannot be 0. Okay, this is not possible because this is not interpolating this thing. Okay, so beta can't be 0. So that means we have to solve one more. One more inequalities need to be solved. And that will finalize. So alpha is 0. Now let us take the inequality which was pending. So p of 2 is minus 7. Now let's solve this. So you get minus 7 equal to 2 minus 2 plus 1 and plus 2 times 2 plus 1 minus beta into 2 plus 1 and into 2 minus alpha. Okay. So what I get, minus 7 equal to 2 minus 3 plus 6 minus 2 beta, 2 plus 1 to 3, 6 beta. So minus 6 beta into 2 minus alpha. So that gives me 2 minus 3 minus 1, 6 minus 1, 5, 5 minus 7 is 2. So I get 6 beta here equal to 7 plus 5, 12. So beta equal to 2. So I got beta to be equal to 2 and alpha equal to. So alpha plus beta will be 2 plus 1, which is 3. So the answer should be 3. Okay. Now let's solve this problem from Fourier series. It says sine pi x is given by this, then a0 plus a1 pi is what? Okay. Simply find out a0 first quickly. So a0 will be simply, since this is between 0 to 1, it's not from minus pi to pi, to simply integrate from 0 to 1. Okay, f of x. So that will give me 0 to 1. Now sine pi x between 0 to 1, it will give me minus of cos pi x upon pi, and limit goes from 0 to 1. So you get minus of cos pi, which is minus 1. Cos 0 is again minus 1 over pi. So you get 2 over pi. Okay, and since we want a1, so instead of writing the entire term for n, I'll say it is only for a1. So a1 will be integral 0 to 1 f of x, that is sine pi x into cos x dx, and pi x, sorry, it's cos pi x. Fine, but we know that this integral, okay, this integral right here will be 0. So a1 is 0. So therefore a0 plus a1 times pi will be equal to 2 by pi plus 0 into pi will give me 2. So the answer is 2. Okay, and I'll write down the formula which I used here. So a0 is integral 0 to 1 of x dx is for calculating the Fourier coefficient a0, and for an it is used as 0 to 1 f of x into cos n pi x, and for dn it is integral 0 to 1 here in this problem. Okay, otherwise it is 1 over pi and then from minus pi to pi. This is what we have seen in Fourier series, but since this is given from 0 to 1, we will simply integrate between 0 to 1. So for that purpose, I get here f of x into sin n pi x. These are the Fourier coefficients. Okay, so the answer here is 2. And now let's solve this problem 51. So 51 is given that we have to find out limit n tends to infinity integration of from 0 to 1 fn of x dx. So let me consider this. Limit n tends to infinity, and here 0 to 1 fn of x dx will be equal to limit n tends to infinity integral 0 to 1. What is fn of x? So 2n into x power n minus 1 on 1 plus x dx. Okay, let us solve this. So our goal here is to use DCT, dominated convergence theorem. Okay, so limit n tends to infinity, and then just wait, 2n, keep 2n outside, and then apply the integration for 1 over 1 plus x into x power n minus 1 dx. Okay, apply the integral sign. Okay, perform integration by parts. That is called also called UV method, what you fondly call. So if I apply that, then this will be my u and this will be my v. So if I apply that, I'll write down a little large. So limit n tends to infinity. Now this is from integration of 0 to 1. Okay. Now this 2n will be alive, and then in u will remain as it is, and integration of x. So that will give me x power n upon n plus 1. And the limit will go from 0 to 1 for this quantity. Oh well, since now this integral will be lost because I have applied here integration, and then minus of this integral 0 to 1 will remain here, and here I'll be getting derivative of this. Okay, so that will give me minus 1 over 1 plus x square. I hope you know how to apply integration by parts. Okay, so minus 1 here, and then integration of x over n plus 1, and then dx. Still I have here 2n. Okay, now watch it. So it is not n plus 1, it's just n. Okay, it is simply n. And now just put 1. So limit n tending to infinity, as n and n will get cancelled. If you put here 1, if you put here just 1, so you get 2 into 1 upon 1 plus 1 is 2, minus if you put 0, you get 0. Right? And minus limit n tends to infinity, this will be minus and minus plus. And then 2 and n will get cancelled. It will be 2 times limit integral 0 to 1 x power n upon 1 plus x square dx. Okay. I'm wondering where is one n is missing. Where it is? Just a moment. N power n plus 1, 2 is fine. 1 plus x is again fine. What I have here is u integration of v dx minus derivative of u, and then integration of v dx the whole dx. So this 2n will be played for both. 2n will go for both of them. So I'm getting here 2n. I want to apply DCT here because to apply DCT, this thing has to be uniformly convergent. Okay. So the limit function at x equal to 0 is 0, for at x equal to 1. It is giving me a different function. So there should be one more n pending. But where it is going? 2n x power n minus 1 upon 1 plus x. Okay. There is some mistake here. What? No, let's check what went wrong in this video. 1 second. Yeah. So I found this is true, and as n tends to infinity, this is my wait a second. Just let me first calculate this. So this will be 1, and now let's consider this part. Okay. So suppose this is my Tn of x. So that is nothing but x power n over 1 plus x square, and x belong to 0 to 1. Since x belong to 0 to 1, so this quantity right here is uniformly convergent to 0. Okay. So as n tends to infinity, okay, limit n tends to infinity, fn of x equal to 0. Okay, and we know that if f is uniformly convergent, okay, if fn is uniformly convergent, I'll use this result. If fn is uniformly convergent to f, then integration over a to b limit n tends to infinity fn of x dx is same as limit n tends to infinity integration over a to b fn of x dx. These limits can be interchanged. So my f of x is 0. So basically this entire quantity will be 0. So I get answer just 1. Okay, so answer here is 1. There are n number of methods to solve this problem, but I find this one to be very useful. Okay, now there is just one more, question number 55, and it's quite easy. And let's solve this. So this is a transportation problem. Okay, they want the optimal cost of transportation. Okay, so just let me write down. This is source destination M2, M3, M4, and this is P1, P2. Supply here is 6 and 5, while the demand is 1, 2, 3, and 5. Okay, and the entries filled are 1, 3, 5, 8, 2, 5, 6, 7. Okay, 6 plus 5 equal to 11, and 5, 3, 8, 2, 10, 1, 11. So this is a balanced transportation problem. So here, to find out the optimal cost of transportation, we can apply either a least cost method. Okay, so here you can apply least cost method, or you can even apply northwest, but I'll suggest you not to apply this northwest because it will not give us the optimal one in some cases. See the way how it goes. You have here northwest problem, northwest first, and then apply least cost. This method gives a little less accurate value. This gives a slightly better. And then we have Vogel's approximation method, and then we have Modi method. Okay, we generally go to VAM, but since this is quite simple, so least cost will perform best. Okay, if there are more than two rows or more than two rows, then we will apply VAM. Okay, Vogel's approximation method. Vogel's approximation method. It's called VAM. But here I'll apply least cost. Okay, so you can apply here least cost, or you may even apply northwest. But applying least cost first, let's check by least cost what we get, and then we will check even by northwest. So if you apply least cost, then consider the least element of this metric. So I find here it is 1. Okay, now let's assign values to 1 and just check 1 and 6. The minimum of 1 and 6 is 1. So 1 is assigned here. So 1 minus 1, it will become 0. So this quantity is now lost. Okay. Now the least element is again 3. So let us consider 3 and assign for 2, and then it will be minus 1. Okay, because 1 you have absorbed, so 6 minus 1 will be 5 here. So from between 2 to 5, 2 is minimum, so assign 2 here. So 2 is now supply is demand is full, so this will be wrong, gone. And now the least element is 5, so let us apply from between 3 to 5. So it will be again 3. Now the again demand is filled, so this will be gone. And now the least is 7. For 7 you have 5 and 5, minimum of 5 is 5. Okay, so the optimal cost will be simply 1 into 1 plus the value which you have assigned. Okay, the same problem they even had asked in 2017. Okay, you can even see that video. In that I have applied Vogel's approximation method. Okay, but here I'm doing least because there are only 2 rows. Okay, plus 7 into 5. So if you apply, you get 1 plus 6 plus 5 into 3, 15 plus 35. Okay, so that makes it to 57. Okay, that makes it to 57. So the optimal cost is 57. Okay, so that's all. And thanks for staying connected. See you in the next session. Thank you for watching.